Yes. Hello, welcome everyone. Thank you for joining us today in this talk. I'm going to quickly introduce the group very quickly because you know everything probably about it. We are the Madrid-GUG user group. We talk about everything related to Groovy and the ecosystem related to it. So we talk about Grails, we talk about Gradle, about Groovy itself. We don't talk about Micronaut and about a lot of different things. We record all of our talks. So we have like 8 or 9 years of recorded talks in our webpage, madrid-gug.com. So if you want to give a talk at our group, just contact me. These are the group Twitter and my account. And very quickly, we have open collective to support the group. You can donate something if you want. We have some sponsors that I will show you later, which basically are Adaptavist. We use their Zoom account for this, and they pay the meetup. B2Boost, Luis works at B2Boost. They've been supporting the group for a long time. Luis will introduce the company for sure better than me. We also have licenses from JetBrains. I will raffle one of the licenses after the talk. OCI sponsors the group. They used to pay the drinks we had after the talks. So I have like a lot of money there from when we want to basically join together again and do in talk presentations. We will have a lot of money to spend in drinks or whatever we want. And finally, Bridge that pays for the screen capture or the recorder that we used to have or we used to use for recording the talks in person. So I think that's basically it. I have for the raffle after the talk, you can sign up in that QR code or that URL, bit.ly Madrid-GUG-raffle. So if you want to enter in the raffle to win the license from IntelliJ, sorry, for JetBrains, join there. I will share this link after the talk, so don't worry if you haven't signed up yet. And that's it. Now it's your turn, Luis. Thank you.
Thank you.
Hello. This 1 second, please.
Yes.
I need to stop this. Stop share. Yeah, share your screen, please.
There we are.
Excellent.
So thank you, Ivan, for the introduction. So this is a talk. This talk is a summary of the techniques and best practices we have to learn to build on top of the Vavr functional library and how we integrated them into Grails for applications. Some are in-house helper classes, some are directly from the Vavr core library. So let's jump into it. First, who am I? So I'm Luis Muñiz, and yes, that's 25, as in 25 years of Java. So my career started developing sexy menus, or at least that's what I was thinking, in Java applets. And but I finally found out that even then they were too ugly to go to production. So my applets never saw the light. Then I found out that I was more gifted towards backend work than front-end work, and specialized in that. So, but long story short, I came to Madrid a couple of years ago and discovered this lovely Groovy user group that had always very active talks and very interesting talks, and I thought that it was time for me to contribute a little bit to the corpus of talks that are already recorded. So thank you for the opportunity, Ivan. So I'm CTO at Sparkers. Ivan talked about B2Boost, but Sparkers is a spin-off company of B2Boost. I'm also CTO at B2Boost. So I've been at B2Boost already for something like 20 years. And I know the good code and the bad code, and there's a lot more of bad code in this company, obviously, because the bad code, good code turns into bad code. So this is a kind of an attempt for you to show how you try to cope with this situation of handling bad code. So what is Sparkers? Sparkers is a company that handles data for the entertainment industry. So we deliver market insights, we do product tracking, we also implement custom solutions to the entertainment industry. We usually make this by measuring data, measuring sales, measuring streaming audiences. Basically, that's what Sparker's scope is. As a software engineering practitioners also, we stand behind test-driven development, clean code, iterative delivery, and we have been working with Grails and Groovy for a long time now. So, disclaimer first. So, this is going to be an opinionated talk, right? So, monads, they have their advantages and their disadvantages. Also, I'm not going to explain theoretically what the monad is for the 100th time. So you're not going to get a course on category theory and this and that and what a monoid is. This talk is really a very basic and practical approach to how we apply monads, and try happens to be a monad. Again, everything is a trade-off in architecture and in design, and you will be able to spot some of them in this talk. I know not everyone will agree with me because someone else is willing to make different trade-offs. So it's okay. I mean, I am very interested if you have challenges to our approach to hear about them. And but this is shaped by our experience, or maybe warped by years and years of misadventures in code. And yes, so let's go and have a look. So what's the overview? First, we will look a little bit at why we are interested in error management. So again, why we don't like too much how Spring does it. And then how we solve that, and how it will affect how we construct a Grails application. So what about errors? Well, an error can happen anywhere in your application. So it is important to be able to recover from them and to handle them. We want to be able to handle them in a central place to have consistent error management. A nice idea also is to do it near the point of entry. What I call the point of entry is wherever your application gets control of the execution of the CPU, right? So the point of entry of application is where the error management should be. So because you are having a conversation with whatever process or entity that has given you control, and so you can either continue the conversation by replying with the happy scenario, what is expected, but you should also be able to reply with an alternate scenario, which means maybe recovering from an error or just communicating the error. So the error management should be near the point of entry of the functionality. And of course, the comparison to my last trip to the postal office, only at places like that, will you get sent to another counter to handle exceptions to your requests. The person receiving the request should be providing the response because they have the context of the conversation. Imagine you have to continue the conversation with another person. I mean, that's probably happened to you some time in the postal service or in whatever government office. So another problem is that the point of entry is usually far away from the origin of the error. So the furthest away you get from the origin of the error, the more you are in danger of losing the context of what caused the error, what information was available when the error happened, and try to make sense of the error. You might need the context. Analyzing for that the cause is harder because you're further away. And it's harder to recover if you only are aware of the error whenever in the point of entry. You might not know exactly what has happened. You might just know that something has happened, and might already be too late because you are potentially stack frames tons of stack frames away where the error happened, and it might be impossible at that moment to recover intelligently. So how does Spring does it? So an error can happen anywhere. So they choose the construct of throwing exceptions to signify that an error has happened, which is basically a go-to from where the error has happened to the place that the error is handled. It is hard when you look at the source code to know where an error of a specific place will be handled, because the transfer or flow of control is now not explicit. We want also central error management. Usually the best implementation I saw of this in Spring is using exception handlers, where you have to map a specific exception handler to a specific class of exception. Again, because it is far away of the error, usually exception handler a specific kind of artifact, which might already be too far away from the logic. It might be the last step before returning control to whatever has given you control. It might be too late, for example, to connect to a service, to create a transaction, etc. So you end up probably with complex static exception hierarchies to be able to match to have a nice match between exception handlers and the kind of error, the fine-grained error that has happened. You will find in your code many catches, logs, and rethrows, because you might catch a checked exception, and then you might want to throw a runtime exception because you want to cause a rollback or whatever. So you will find your code littered with constructs like try, catch, and rethrow exceptions. You might also have to hunt your logs for error causes, because some of the exceptions you will log the internal exception and throw another exception. Then the only place where you can have actually context is when you log it. And then, of course, you can say goodbye to consistent error handling, because everything is going to be so diffuse inside your application. Sometimes you will even see the catch and swallow anti-pattern, where you catch an exception, you don't know exactly where the exception is coming from. You know that sometimes an exception happens there, so you catch it, and because you don't really know what it's coming from, just hope for the best and swallow it. And then I think that's the real reason why I started looking for an alternative, is that Spring couples the transfer of control with transaction management. So whenever you throw a runtime exception and it crosses the boundary of a Spring bin that has been instrumented with a transaction manager, the transaction will be rolled back. So you don't have a choice about that. If an exception gets out of your method, the transaction will be rolled back. And that, I think, is a little bit too crude of a way to handle it, because sometimes you want to be smarter. Sometimes you might want to ignore the same exception in some cases. Then in other cases, you want not to ignore it and accept the rollback. So I found in bigger applications, this kind of transaction management created ugly code. So again, checked exception become a problem, because if you want your checked exception to generate a rollback, then you have to wrap it in a runtime exception and throw it again. Ugly. So A couple of examples that I saw by looking 15 minutes on over the internet. It's stuff like this, you know, where you have successive catch clauses where because it goes from more specific to less specific, it goes, your situation is worse and worse because you know less and less about what has actually happened. So if you get an SQL exception, imagine you get it in the controller, you're already screwed because you're not going to recover from that. But if you don't even know that kind of exception, you just get a kind of exception, you're even more screwed. I mean, you can't just give up, return an error 500 and be done with it. Let the client deal with the consequences. I saw even worse things. I mean, I have done this. I mean, the first one who hasn't done this should throw me the stone, right? So I have done this because something should never throw an exception. Well, don't do anything. But this usually means that you don't really care if an exception happens. So what this means is just an excuse of, yeah, let's just be lazy and don't care what happens and hope for the best, right? So finally, my conclusions is that unchecked exceptions are not really your friend because they are basically go-to statements. They don't let you see clearly where the handling of the error happens because it's just an invisible jump from one place to another. Checked exceptions are definitely not the response, and Spring is right to get rid of checked exceptions. And I mean, thank God that Groovy has gotten rid of having to catch checked exceptions. Most code, that's very important. Most code, unless trivial, is not exception safe. I mean, an exception can happen anywhere in your code. And to think that because you created a little try-catch construct in one specific place of your code, that you're safe from getting transported from one moment to the other into your controller is an illusion. You should not assume that your code cannot, that you catch all the possible exceptions in your code. Exceptions are expensive to throw. To create an exception, you actually need to inspect the whole stack frame and create a data structure that will allow to report the successive stack frames that have been constructed to be able to log it properly. So, and this is a very expensive operation. You can have memory leaks, unclosed files, sockets, partially written files, and on, everything, wherever you throw an exception. So using that as a central strategy to report errors is also problematic because of that. This results in brittle applications, and usually without the opportunity to intelligently recover from errors, because you're already too far out of context to be able to recover from errors. And you shouldn't take my word for it. I have, again, done a little bit trip on the internet and tried to get some screenshots of articles that are talking about that. And it's really, I mean, you see it's all over the place. That exceptions are not a nice way to handle errors. So let's stop complaining and let's look at solutions. So what we need error handling next to the point of entry. We need to be able to preserve the context of the error. We don't want to break flow of control, and we don't want to break function composition. And we want also to allow either locally or globally recovery of errors. So we want to be able to recover the error where it happens. I want also be able to trickle down, to let the error trickle down without too much effort into the top layer of the application to be able to manage the error. So these next slides show a little bit the solution that we provide. So how it affects a full Grails application when you try to implement this solution. So the first thing we did is to embrace HTTP status codes, not only on the controller layer, but also everywhere in the application. So whenever some piece of logic inside the application throws an error, we look up the HTTP error codes and usually find the error code that is necessary, be it a conflict, or you don't find something, or there is a bad request. So basically the illegal arguments exception is a bad request, etc., etc. You can find an HTTP code that will match your error case pretty nicely. So embrace HTTP status codes. And what the effect that this has is that whenever you throw this error, you can, if you let it trickle up to your controller, the controller only needs to recuperate this error code and set that error code into the HTTP status. So there is no impedance, there is no misunderstanding about what kind of error has happened, and wherever it has happened, you will be able to translate this error into a meaningful interpretation for the client. Of course, I should say that most of our microservices are HTTP based. So, but this can also be applied to other kinds of microservice, message-based services, etc. We'll get back to this a little bit later. But of course, my talk is a little bit slanted towards that interpretation of the control flow. So I hope you will forgive me for that. So we have reused the HTTP status codes, and we have created an exception, an error factory called error context, and it is a special runtime exception that does not fill out the stack by default. So it is not expensive to generate by default, unless you want it to. But by default, the factory methods will not create an exception that has a full stack. It will just vehiculate the kind of error and the context of the error. So, example of factory methods inside the error context. So you will see internal error. Each of these methods will accept the appropriate arguments, and the most will also accept a context map with which the originator of the error can fill out with whatever business context is necessary to be able to recover or to create a proper error message once you handle the error. So these are a couple of examples. You will find the typical HTTP status errors, like internal errors, method not allowed, conflict not found, etc., etc., etc. These are factory methods that will always return an error context, which are extensions of a runtime exception. So again, the next part of the solution is to not break flow of control and maintain function composition. So meaning that, sorry, I'll just take a bit of water, thank you. So when you call a method which throws an exception and want to compose it with continue the flow, the exception will break function composition because it takes you out of your context. So we want to maintain function composition. How do we do that? Well, we try to enforce the contract that a function should never willingly throw exceptions, and try to protect against unwillingly throw exceptions too. So let's enforce the constraint that a function will never throw an exception. And then we use the famous Java slang, which is now called Vavr Try Monad. So there's a little bit of a funny story with Vavr and Java slang, is that a couple of years ago, they were called Java slang, and Oracle kind of forced them to change the name because they had a copyright claim over the Java word. And Java slang at that moment did a very, very clever thing. They just came out with this nice logo, which when you turn it around, is actually Java upside down. I find that is brilliant branding and a story. Just a snub to Oracle and their tactics sometimes. And they have great, I mean, I have to say that Oracle has great engineers, great technology, but sometimes their legal teams are not the best of the team. Okay. here a solution. So we use this class called try, and the try class can embed two different kinds of values. It can embed a certain type, which is the parameterized type T here. So it could be a try of a string, for example. So in case of success, in your method, can you return a try of a string? In case of success, it will embed the string that you want to actually return. In case of failure, it will embed, the string will be undefined, it will be null or something. But in case of failure, it will embed a throwable. So a kind of an error. So your method, you can, in terms of the signature of a method without looking at the exceptions, you can take into account that it returns a specific value, but it can also fail. Once you do that, you can change the signature of your methods. Here we have two methods, divide and multiply, and two safe methods called try divide and try multiply. And we use this construct of try off. Try off accepts a closure, and whatever is executed inside that closure, if it throws an exception inside of it, the exception will not get out of the off method, but it will be wrapped inside a try failure. Okay, if it doesn't throw an exception, then whatever result divide here returns, which is a number, it will be the T. It will be the embedded value of the try object that is returned by try divide. So basically we change here, we switch the try off for the try catch for a try off. How do we make sure that we still can compose functions? Because if a division attempt is returned on a try of an integer and not an integer, we cannot multiply a try of an integer with number 2, for example, or number 3. So if we want to implement the line above, so we want to divide 1 by 2, multiply it by 3, and add 5, okay? To do this with the try monad, we have to do make a little bit more syntax. This is, of course, a naive implementation, so you can write it easier and more elegantly, but this is the first approach to show you how it works. So the first call to try divide is an attempt, returns an attempt to divide. Sorry. Then we use that attempt to divide, and we compose that attempt to divide with an attempt to multiply with try multiply. Okay, and then we have this multiplication attempt as a result. Once we have the multiplication attempt, we will compose that multiplication attempt with an attempt to add 5, not with an actual operation to add 5 to it. So the composition, how you compose try objects, is via the two methods map and flat map. And there is only one difference between map and flat map. Flat map expects the closure that you pass to it to return a try instance, and map does not expect, like you see here, it plus 5 is not a try object, it is a number. Okay, so map, what it will do is doesn't expect it plus 5 to be a try, but it will wrap the resulting number into a try and result, as a result, the sum attempt, which is the try of a number. Okay, so you will see, depending on what you're using, if you have a method, for example, that comes from an external library, you might use map. If you have a method that is already returning a try because it's part of your application, then you use flat map to compose. So this is the naive implementation. You can write it like this also, which is still admittedly not as simple and easy to read as the first line of code that we have here, but at least it's a little bit more palatable. You don't have to create temporary variables and stuff. Okay, so a little bit of a side note. So you did not really think that I was going to resist trying to explain monads. However, I will not break my promise. I'm not going to explain monads theoretically. I just want to give you an intuitive understanding of what monads are good for and how you can interpret them in a software engineering context. So just one slide, then I'm leaving you alone. So in classical languages, function composition, it's hard-coded in how the language is written and how it's understood. If you write f of g of x, means that you first call g of x, then feed the result returned by g of x into the argument of f. This is defined by the context, by the syntax of your language, and also by the interpretation given by writing g of x. The interpretation of writing g of x is you invoke g of x, you call this method. So in monads, g of x map f means to compose the result returned by g of x with a function f. So because you can implement map differently for different monads, this means that at the language level, now as a user of your language, you have the possibility to redefine what it means to compose functions. And this is very useful. For example, in monad try, composition means only compose with f if g of x is not a try failure. This means that you can, if g of x returns a failure, you're not going to bother calling f, okay? But if g of x is not a failure, then you're going to compose and feed the result of g of x to f, okay? The same way, if you're using a future, composition is defined differently. Composition there is mean that you should compose with f whenever the value in g of x becomes available when you are using a future. And also in a list, because list can it be interpreted as a monad too, composition means to apply f to each element of g of the list. So you see that when you write monads, you can actually redefine, reprogram what it means to compose functions. Of course, functional languages with native monads have a lot nicer syntax for this. If you look at how Haskell expresses the composition, they use for comprehensions and for list comprehensions, and it's quite nice syntax. But in languages like Java and Groovy, we have to use whatever syntax is available to us. And I think, yeah, so already in Groovy, it's kind of a lot nicer than how it looks in Java. Okay, so how do you handle success? It's over. We're not talking about monads anymore. How do you handle success and failure? Here, some attempt is an attempt to sum, to divide 10 by 2, add 3 to it, and add 5 to the final result. So this obviously on the left is going to be a success. If you look at the piece of code on the right, we're trying to divide 10 by 0. This will not be easy to do. So on the left, you can assert that some attempt is successful by using the isSuccess method. And you can also call a higher order function where you provide a callback function in form of a closure, where you can give the monad function to execute in case of a success. On the right, it's very similar. So you have an isFailure method also in attempt. And here, the try divide will return, of course, a failure because you cannot divide 10 by 0. And then the flat map, the try multiply, and an it pass 5 pieces of code will never actually be called because try divide is already returned as a failure. And as we saw before, composition with try means that I only compose this method, with this function with this function if try divide returns a success. So you have again this on failure callback higher order function that accepts the callback to be able to handle the actual underlying throwable. So you see here the parameter of the onSuccess method is a number. It's the underlying number that is the result of the sum of the chain of arithmetical operations. And here on failure, we know that a failure can only be a throwable, so you will get the it is going to be a throwable. So how do we transform a failure to a success? You can do it like this. If a sum attempt is a success, it's going to return the success. But if it is a failure, then you have a chance to replace the failure with a success. So here, for example, we can say, if it's a failure, just return 0, okay? Or if it's a failure, call this closure, and this closure should return its own try. So you can even create here a function that will handle the error. You can also use the recover method. So the recover method, the difference between or else with the closure and recover means that you can specify a kind of a kind of exception, just like catch. You can specify the exception. You cannot omit the class of the exception completely. So it's just going to recover any kind of exception. But if you specify the kind of exception that you recover from, then you will see that the it argument of your closure will be of type arithmetic exception, and then you can invoke some kind of recovery code that will decide how to fall back into a different value. This should return a number, like decide fallback should return a number. So recover is like map, just it will accept the error as an input. You can also have an equivalent of flat map, which is recover with, and recover with expects you to construct your own try, failure, or success and return that. Okay, so that's again the difference between map and flat map. You see it here, it's the same. Map is the equivalent, the recover is the error recovery equivalent of map, and recover with is the error recovery equivalent of flat map. Okay, how do you map success to failure? That's very easy. Sum attempt is in principle a success, so you can compose sum attempt with an additional function and say, if the number is bigger than 10, then I'm returning a failure. Otherwise, I'm returning just a success. So here's the basic tools. How do we integrate them in Grails 4? So how do we modify the design of our Grails 4 application to be able to take full advantage of this? So this is the most complex slide of the presentation. So please bear with me. I just want to show the different layers of the Grails application that are going to be involved, and also more general design decisions here that usually I found that these are necessary when you start complicating your application, when your application starts becoming more complicated. So because usually in toy projects, what you see is that the domain class is something that travels from the data layer to the controller very easily, and it never changes. So whatever you show in the JSON has exactly the same schema than whatever you have in the database, and that's usually not the case as soon as you start having complicated applications. So what we have here on the left is that the API client communicates with our API through JSON. So we have the data binding and the JSON rendering parts of Grails that will first bind the JSON to a command object. And on the other side, when you return some kind of structure from the controller, it will render that structure as JSON. The controller will use that command and execute the command. The commands actually here again there is a little bit of a step of translation. The service in our designs should not accept to be given commands. So what we try to do is create these properties classes that actually encapsulate the values that are necessary for a service method to do their job. Instead of creating a service method that has 15 parameters, we just create this model. It's like a model of the logic of the business logic. So author properties contains just all the properties that an author should contain to be able to send it to the author service. The author service will interact with the author data service, and this here we are already talking Grails domain objects. So between those, they both use Grails domain objects. The author service returns a Grails domain object, and then the command's responsibility is to transform this Grails domain object into an author resource, because sometimes and quite often, the data that is returned back to the client doesn't match the data that is in the database. So we have to introduce this additional concept of a resource object that will be mapped into JSON by the JSON view. On the right, you can see the same thing I just explained, but in more structured way. So we have here the author controller that receives a command. The command has an execute method and returns an author resource. And we have this extra validation support trait, which basically the only thing that it does is that it wraps the validate method of validatable and returns a try with this. Instead of calling validate and testing the value of validate, we just use try validate, which will either be okay or return a failure containing the correct validation error. You see that author properties basically, for example, only contains the name. So the properties are inherited to the command from author properties. And the author marshaller knows how to transform an author into an author resource. Okay, so maybe later, if there are questions, we can talk about this. But I don't think we should go too deep into this design, which is basically, I mean, you do this however you want. So here's the code that of one of our controllers. So you see that the methods in the controllers are basically one-liners. We have a command that has been mapped from JSON. The commands have execute methods, and they return a certain type that is forwarded to the respond OK, respond created, respond deleted, respond whatever in controller responses. Okay. So in controller responses, this is a small snippet of code. You see that the respond OK method, for example, accepts a try object. So basically, this means that this controller should respond to an OK code unless it's a failure. Okay, so if it is a failure, then you will have something like you have in respond delete here below. If there is a failure, then we should call the handle failure method. Otherwise, we respond with a specific payload here in the deleted, because the payload needs to be empty. We respond like this. But basically, you see that these methods in the controller responses responsibility is to look at the try object. If it is a failure, you get, here you see the handle failure. You take the code that has been wrapped in the error context, and you set the status with that code. And then you forward the error context itself into the JSON view that will display it. And here below, you have the JSON view that will just extract the information that is inside the error context and create some kind of JSON structure containing the error description. This is again something to evoke the diagram, the class diagram that we saw earlier. This is the command object. And the command object inherits from author properties. So this means that it can't send itself into the author service without coupling the author service to the command object itself. It inherits from validation support, so it can call try validate to try to validate the data that has been bound to it. And it implements the author marshaller trait, which means that it can transform an author returned by the service to an author resource. That is which the class that it needs to be able to return. So here we have the real logic of flow of the orchestration of the use case to implement is inside the command. Here we have facade service. So this is the typical service where we have to do the transaction demarcation. Like we said, we don't let Spring do the transaction demarcation anymore, or at least the transaction handling, the rollback. So we do this in specific entry points of the facade services. So in this facade service, the update method, we call a higher order function with transaction status, in which we inject the transaction status variable that is created in Grails whenever you annotate a method with @transactional. This means that if the closure that is being passed to this method returns a try failure, it will call the set rollback only method inside the transaction status and do a rollback of the transaction. But it will only do it because you did it. If you don't do that, the transactions will not be rolled back because nothing in your code is throwing exceptions. So Spring will not roll it back. You have to roll it back on your own. This is why we have provided this with transaction status method to allow you to explicitly decide where your transaction starts and where it's rolling back. So any method here, to, for example, try get could return a not found. Ensure author exists is another method that could return an error. For example, what we have here is that when you try to save a book and the author is not existing yet, ensure author exists will create the author in the database with an author service and author data service. And then you call, whenever the author has been created, then you call the book data service and try to save the book with the assigned author. If this method, the try save here, gives us an exception or returns an error, we need to make sure that the transaction that has happened inside the author service is rolled back. So this is why we do it with with transaction status. A data service, what we do here is that we have, of course, the typical generated methods that we take advantage when you create a data service. But we also have monadic versions sometimes of some methods. For example, try save will first try to validate the book. So you have validation logic here inside, very deep in your service. And if this validation fails, it will trickle up to your controller. You don't have to put if validate or if save in your controller. This is handled. The error will trickle up to your controller and you will be able to return a proper validation error without having to compromise and putting a lot of try catches or even if else's in your controllers. So the book is validated, and then we try to save it in the database. As you know, saving an object in the database can cause exceptions because you might try to add a line that is already inside, or you might have some concurrency access. So you can never say that this will not cause an exception. So this is why you have this handle validation exception, which is provided by the service validation support, which will protect us from any exception happening in save book. Here again, for example, try get. I don't like the fact that get book.get returns a null if the book doesn't exist. I think that if you give the book an ID, asking for the book to return none, it's like the ID that you give is an invalid value if it can't return a fully formed book. So this is why I prefer using this version of get, where if the get ID is null, then I will return a not found error. Okay, so we are already almost there. What are the key takeaways of this talk? The honest functions. The functions need to announce their return type and promise not to kick you by throwing exceptions. You keep in control, so your application can, if needed, attempt recovery close to the source of the error and still keep the feature to let errors trickle down into the controller for handling. You get very, very simple generic controllers thanks to traits that are specialized in error handling, like the controller responses, and traits that are specialized in transforming domain classes into resource objects. The controller methods are usually reduced to one-liners. And then you have explicit transaction management. For me, it's a plus, where you decide where the transaction needs to roll back if there is an error, because you might want to recover from a failure in one use case, and the same failure for another use case might be a reason to roll back. So using exceptions for this is really problematic. And another nice feature is that command objects are the ones that orchestrate the logic. So you can really have a one-to-one mapping between a use case and a command object. So that's it. That's the final slide of my presentation. I hope you have liked this presentation. So again, adopting the trimonad means adapting several parts of the patterns that we use in Grails to really be able to take advantage of it, because if you use it only at one place, you will see that it will disrupt your code. It will create ugliness inside your code. You need to be able to use the same, to do it, use the flow of the same concept, let it percolate through the application to really reap the advantages of this. So I hope it has, so again, I hope you like the presentation, and at least it will make you reflect on how to improve your application robustness, okay? And I'm happy to discuss whatever. Oh yeah, we're hiring. So please, if you have friends that are looking for a job, Groovy guys and Python guys, we have offers where you can get in our workable site, or just contact me. Thank you.
Thank you very much, Luis. Really, really interesting talk. So if any of the attendees have questions, please write them on the chat. So Luis can answer them. Can wait a few minutes. So nice talk. I already knew Vavr. You probably know that. I gave a talk at Reach like, I don't know, 3-4 years ago about it. We were using that Vavr library in a Grails project, but not in every single layer like you show. We only use it in a few different places, but it's a really, really interesting approach. The nice thing I really like, and I try to do it always, is keeping controllers as single as possible. So yeah, I totally agree with you. If the controller method is just one-liner, that's amazing, because you can just test in that's basically one thing. You have probably two test cases for that controller. One when the validation works, and one when the validation fails, and that's it. You don't need to put any extra logic there. So yeah, really, really interesting approach.
Thank you. Of course, you see that the syntax can get a little bit heavy to read. You need to get used to this, but I hope most people can get used to that. I think that the advantages are outweighing the disadvantages, in my opinion.
Yeah, probably one question I have is it this complicated for so when you have a new people joining the team, how much time do they need to kind of get used to this, right? Even if they don't, or even if they have used this in the past or not. So is it too complicated to start thinking in this way of doing things and wrapping everything into this try thing?
Mm-hmm. It is a little bit more complicated, but I would say that it is much more complicated for them to understand the real business than to understand this. I think it did take a lot more time to understand all the different systems and how they work and what they're supposed to do than to understand how a monad works. Of course, it doesn't make things easier. So we try to create template applications where things are solved. And the more example code you have where you follow the right pattern, the easier they are just, copying stuff and they're getting inspired of existing. Of course, if you have code that is not done like this, then they will sometimes copy the bad code, right? Mm-hmm. Yeah, so it is not making onboarding easier, of course, but I think the onboarding is a lot more heavy because our systems are very varied and complicated.
Yeah, I can imagine. So yeah, for example, I think that so another question is that I think that probably reviewing pull requests will be a little more tricky or complicated, right? Because you need to make sure that every piece is in the right place and you don't do tricks like, yeah, I need this repository here, so I inject the repository in the controller and that's it. So I just skip all the layers, right?
Yeah, that one hurt. Just you saying it hurt me deeply because it's something that happens, of course. So yes, you need to do code review, and I mean everything needs to buy. People need to buy into the approach. Okay, so and again, if they're not going to do it consistently, it makes the application actually uglier, I think, to just do it in one place. I mean, you can just create maybe a barrier where you start using try from one moment to the other, something like this. You can create these things. Yeah, but code review is harder because it's harder to understand the code. But then it's like in Scala, when the types don't align, your code is probably I mean, when your types start to align, then your code is probably okay. You don't even have to look at the implementation. when the type returned by one function enters is okay with another function, then it's probably this Odersky himself who's saying that. So the same way, when your result of your try is okay with the input of the next monadic method, then mostly your types are aligning and your code is going to be more or less okay. It helps a lot to use compile static also. I really recommend that. Yes.
Yeah, sure. We have a question from Jorge Aguilera. Can this work in a Rails 3x application?
Sorry? Yes. Yes.
Will it work in Rails 3?
Yes, I mean I just used Grace for as example because it's more current, but it does work on Grace 3. Yes, nicely. Yes.
Yeah. Okay, so anyone have any more questions? Yeah, one question from Alberto. On the handling success and failures slide, how do you get 6 from the success case?
How do you get?
6, the result 6.
Good, you found it. Well done, Alberto. That was a bug. You can't. Well done. Yeah, it's a bug. It's probably I made this impossible. It's wrong. You cannot divide 10 by 2. You get 5, and then multiply by 3. You get already 15. It's impossible to get 6 there.
So you didn't run the test.
I had so many versions of that slide. I got tired of changing it, so let it go.
Another question.
Well done, Alberto.
Do you think this approach is more difficult to debug?
Yes, but then again, you should do tests. So to try, it is difficult. It is more difficult to debug. I will agree with to that. You will find some types of errors quite more often. Like for example, this, if you use flat map and your try multiply is not returning a try, then you will recognize this kind of error quite quickly and see, okay, yeah, I should, my try multiply should return a try. And it's the same thing if you use map and the function that you combine with returns a try, you will learn to recognize these kinds of errors because there will be frequent. It's definitely harder to debug, but it's easier to test, I think. So,
yeah. Okay. Anyone else? Well, I think that will be it. Luis will share the slides and we will post the video in a couple of days. So if you have any questions in the future, you can contact us or contact him. And yeah, that will be it. Thank you very much for your time. Thank you, Luis, for the talk. It's really nice to see that more people are using try there, this try thing in different places.
So I have one question though for the Micronaut guys. Why do you use optional instead of try?
Basically because so introducing a new library in Micronaut, I mean in the core, and use it everywhere means that everyone needs to use. So if we introduce this try thing, everyone using Micronaut needs to use this try thing. It's not like,
of course,
it's not like if we do it in an optional way, right? And optional being part of the JDK, it's easier and it's there. So if you want to use optional in your code, you can. If you can't, or sorry, if you don't want to use it, okay, don't use it. But as it is part of the JDK, we can, right? So basically, it's trying about to keeping the core as smallest as possible without introducing so much external dependencies.
Yep, makes sense. Thank you. Okay.
Okay, so thank you very much.